Hello everyone, this is the first lesson recording for IM2 November 9th, 2020. So we started off with some warm-up problems that's supposed to help you with the quiz. So if you can do this warm-up problem, the first thing you're asked to do is draw your basic 30, 60, 90 degree triangle and 40, 45, 90 degree triangle with the side length. So that means for 30, 60, 90 degree triangle, the short side is going to have the length of 1, and for the 45, 45, 90 degree triangle, the legs are going to have the length of 1. Okay, once you've done that, I want you to find the missing sides of the following right triangle. So there are 5 of them. So please copy this down first and then pause the video and see if you can solve them yourself. So this is what you should have done. You should have drawn your 2 triangles. So I am going to start with my 30, 60, 90 degree triangle. To do that, I am going to create a sort of a flat triangle, which is pretty obvious, which is the short side and the long side. Okay, the short leg is this one. The long leg is this one. The short leg is going to have the unit of 1. The hypotenuse is going to be 2 and root 3. And then the angle measure, looking at this angle and this angle, which is the smaller angle, this is the smaller one. So that's going to be 30 and the bigger one has to be 60 degrees. In contrast, the 45 degree triangle, okay, should look like this, where it does look like an isosceles triangle, not the best isosceles triangle, okay? But when you know that 2 of the sides are equal, then you know this has to be 45 degrees and 45 degrees. Okay, and here is my right angle. That means the leg length is 1 root 2. Okay, so these are 2 triangles that you should have memorized. Okay, and the more you draw it, the more you're going to be able to memorize it and remember it for the future use. And you're going to use this for trig, so you definitely need this. Okay, so looking at this triangle, okay, now looking at A, what sort of triangle is this? Is this 30, 60, 90 degree triangle or 45, 45, 90? It's 60, it's 30, 60, 90 degree triangle, right? So now we are given this is the short leg, this is the long leg, this is the hypotenuse, okay? So make sure you can recognize them clearly. The hypotenuse is the one that is opposite the right angle, and then clearly there is a leg and another leg right adjacent to the right angle, and there is a shorter one and the long one. To go from short leg to hypotenuse, what happened from short leg to hypotenuse? You multiply by 2. Okay, 1 became 2, so that means you multiply by 2. So I am going to multiply by 2, so m is going to be 8 times 2, which is 60. Okay, what did I do from the short leg to the long leg? 1 became root 3, that means I multiply by root 3. Okay, so that means I need to go from here I need to multiply by root 3. Okay, so multiply by root 3, 8 times root 3 is just going to be 8 root 3. Okay, good. Now let's go on to B. Okay, this time, this is 45, 45, 90 degree triangle. That means we are looking at this ratio. We have the ratio of 1, 1 root 2. That means if this is 2 root 2, because this is isosceles triangle, that side length and this side length is going to be the same. So y is also going to be 2 root 2. So 45, 45, 90 degree, the legs have the same length always. Okay, from the leg, one of the leg to the hypotenuse, what happened? From the leg to hypotenuse, we multiply by root 2 to get from 1 to root 2. So that means we need to multiply 2 root 2 by 2, root 2. Okay, so the x is going to be, let's do my math here, x is going to be 2 root 2 multiplied by root 2. Okay, root 2 times root 2 is just 2. So that's just going to be 2 times 2, which is 4. So I know that x is equal to 4 units. Okay, let's look at the next 2 problems. Okay, so then now looking at C, Again, we're dealing with 30, 60, 90-degree triangle because we're given one of the angle is 60 with a right angle. So that means I know that from, okay, so what are we given? We're giving the long legs. That means we're given the root 3, the proportional to root 3. So what did I do to get from the long leg to the short legs? Okay, so I know that going from the short leg to the long leg was multiplied by root 3. That means to go backwards, you need to divide by root 3. Okay, so that means to go from the long leg to the short leg, I need to divide by root 3. So 2 divided by root 3 is same as 2 over root 3. Now we cannot have, so this is why we cannot have the denominator as a root radical. So that means we need to rationalize it. So y is going to be equal to 2 root 3 multiplied by root 3. Okay, and then that the numerator, remember multiplying fraction with fraction, you multiply across and across. So 2 root 3 is the top. Root 3 times root 3 is just 3. So y is 2 root 3 over 3. Okay, now that we figured out what the short leg is, how do I figure out what the long hypotenuse? To go from the short leg to the hypotenuse is just multiply by 2. So I am just, for x, I am just going to multiply 2 root 3 by over 3 multiplied by 2. So that just becomes 2 times 2 is 4 root 3 divided by 3. So that's my x. Now let's do D. Now this time this is 45, 45, 90-degree triangle. So again, remember we went from, to go from the short, one of the legs to the hypotenuse, you multiply by root 2. That means to go backwards, we need to divide by root 2. Okay, so that means whatever the hypotenuse is, we need to divide by root 2 to get to the leg. So x is going to be the hypotenuse, which is 4 root 3 divided by root 2. Okay, again, I cannot have radical as a denominator, so I am going to rationalize it, and that becomes 4 root 3 times 2 root 2. Remember, we multiply inside the radicals together, so 3 times 2 is 6, so it becomes 4 root 6 divided by root 2 times root 2 is just 2. Now I do need to simplify whenever possible. When I say 4 root 6 divided by 2, this is 4 times root 6 divided by 2, and I can, they're common, they're both even, so that means I can divide the numerator by 2 and denominator by 2. So that leaves me with 2 root 6. So x is 2 root 6. Okay? Now, if you know that x is 2 root 6, what's y? Remember, the legs of the 45, 45, 90-degree triangle is always exactly the same because they are isosceles right angle, right? So it's going to be 2 root 6 there again. Okay? All right, the last problem. Okay, so what sort of triangle is this? Is a 45, 45, 90-degree triangle? It kind of looks like it, but do we know that it is? We do not, okay? We cannot assume anything unless we are told explicitly. If we are told that this is 45 degrees, 45 degrees, or if we're told that this length is equal to this length, then yes, we can assume that. However, we do not know that. Is it 30, 60, 90 degrees? No, we do not know that either. But we are given two sides. Can we figure out the third side? What do we need to use? We need to use Pythagorean theorem. Okay, so in this case, we need to figure out which are the legs and which is the hypotenuse. Hypotenuse is this. Okay, and x and 10 are the legs. That means we start with setting up the equation first. Please, please, please do this first, okay? And then that leaves me with x squared plus 100 is equal to 14 squared is 196, I believe, okay? All right, so then um, we are going to subtract 100 from both sides. So we're going to subtract 100 from both sides, which leaves me with x squared is equal to 96, okay? So which means taking a square root of both sides, x is square root of 96, but we do not leave it as square root of 96. We need to simplify. We need to be looking for simplifying radicals whenever we can, okay? Looking at 96, I know it is at the very least divisible by 4 because 4 times 25 is 100. Okay, so that means this is going to be 4 square root of 4 times square root of 24. Okay, so then that is going to be 2 times, but square root of 24, I know that that is divisible by 4 times 6. Okay, so that means this is going to be 2 times square root of 4 is 2, so that's going to be 4 root 6. So the x is 4 root 6, x equals 4 root 6, and that's how we do it. So you can't just rely on one method, you need to be looking at it for different reasons. Okay, so in this case, we use Pythagorean theorem. We did not use 45, 45, 90 degree triangle ratio or 30, 60, 90 degree triangle ratio. Okay, and then we went on to do the quiz. If you missed it because you're absent, you need to contact me as soon as possible to make up the quiz. All right, so then let's just quickly recap what we did last lesson. The right triangles with the same right angle measures are always similar. Okay, so whether it's the whole reason we could do the 45 45 90 degree triangle or 30 60 90 degree triangle ratios were because they were similar triangles, and it was the same with if it was 10 degrees or 20 degrees or 30 degrees or whatever, they're all going to be similar, so that means the within shape side ratios are the same. We built a table for the side ratios using right triangles that are pre-measured. So we did the 10, 20, 30, 40, 50, 60, 70, 80 degree triangles. And then we introduced notation for 3 different side ratios. So the ratio of opposite side to hypotenuse is sine, and ratio of adjacent side to hypotenuse was cosine, and finally the ratio of opposite sides to adjacent side was tangent. Okay, so what are we doing today? We are going to talk about why do we need 3 different ratios and how do we use them flexibly. So to begin, okay, so this is just quick recap again of the last lesson. When you look at this triangle, okay, what are we given? Okay, so to figure that out, you need to put yourself or stand where the angle you are given. This is the reference angle. That means this is where you're standing. That's why you have these 2 footsteps there. You're standing right here, okay? And then you're looking at the 2 measurements that were given. This 12, what sort of side is this? Is this the adjacent side? That means, is it right next to me? Or is it across from me? So it's across from me. That means this is the opposite side. And what about this x? The side with x is across from the right angle. That means x is the hypotenuse. So we're dealing with opposite side and hypotenuse. So which is the ratio with opposite side and hypotenuse? That's the sine theta. Okay, so then we can say that sine of 20 degrees is 12 because that's the opposite side over x because opposite side is 12, x is the hypotenuse. And we know that we're told that sine of 20 is 0.342. So on the next line, I can say that 0.342 is equal to 12 over x. And then from here, you would solve to find what x is. Okay, remember, you can't just multiply both sides by 12. That does not cancel out. you need to multiply both sides by x first.